I am Bindeshwar, and today I am going to show you how we can fit a binomial distribution to real life data. So without further delay, let's get started. So fitting a binomial distribution involves comparing observed frequencies with expected frequencies derived from the binomial probability formula. And the recurrence relation simplifies the process of finding probabilities. So these two parts we have to focus on. The first one, fitting binomial distribution, involves comparing observed frequencies with expected frequencies, and second point, the recurrence relation simplifies the process of finding probability. So we will find recurrence relation. And this technique is useful for testing if a dataset follows a binomial distribution or not. So we know that the binomial probability function is NCX, P raise x and Q raise n minus x. And if you want to know what are the parameters on number of trials, P probability of success in each trial, and Q is probability of failure in each trial. So let us start with the binomial probability function. So that is Px, that is Ncx, and P raise x and Q raise n minus x. Thereafter we will find P x plus 1, and instead of x we will plug x plus 1 everywhere. So we will get this formula. Now let us divide px1 by px. So we will get this expression, and thereafter just transfer this px to right side and we will get this equation. And this is very important for fitting data. Let us see tossing 4 coins. So we have 4 possibilities. 0 heads, it has come 15 times, 1 head 35 times, 2 heads 90 times, 3 heads 40 times, 4 heads 20 times. So total number of tosses if you add, so you will find that is 200. So what will we get here? X bar is equal to, you can say that here summation over fx upon summation over f. So that would be 2.075, and we will compare, that is actually x bar. So x bar would be summation of frequencies into each values of x, and upon sum of all frequencies. So mean we have got, and we will compare mean, like here we will compare NP is equal to 2.075, because binomial distribution mean is NP, and if we compare, so we will get, and the value of n we have already known that is 4, so P is equal to 2.075 upon 4, and that would be 0.5188. So Q 0.4812. Thereafter we can find P0 using like this one formula if we use. So like this one, px we know that ncx p raise x q n minus x. So n we know that already 4. So px0, so 4 c0 p raise 0 q 4 minus 0. So this way we will get, that would be 1 into 1 into q raise 4. So where we are getting, so that would be 0.0536. Q raise 4 I am talking about. Q is this one and q raise 4 is this one. So here if we use px1, so just plug the values. So here that is p0 p upon q and 4. So we will get p1 this 0.23115. The same way p2, p3, p4 we can get. So because that is recurrence relation, so you will get here that value, you will get, keep here, that here and that here. So we will get p1, p2, p3 and p4. Now you can also see from the table what we have calculated. So here that is p0, p1, p2, p3, p4. Here if I write here, so p0, 1, p1, p2, p3, p4. So you have seen that how to fit binomial distribution. So let us see some points. Expected frequency using the binomial model are close to the observed frequencies. The example supports the assumption that the coin is unbiased, and the recurrence relation simplifies stepwise calculation of probabilities. So hope you understood. For more resources, you can visit Post Network website www.postnetwork.co, YouTube channel, Facebook page and LinkedIn page. You can also visit GitHub repositories for a code. So hope you understood. Thanks for watching the video.